Hello and welcome back to our little session on looking at math skills in biology and how to answer the questions. So we've got 6 questions on this paper. This is test number 4 out of 5 tests. So this one then. The diagram below shows a sperm cell. The length of the sperm cell from the tip of the head to the tip of the tail is 50 micrometers. Estimate the width of the head of the sperm cell. Now what I did here is I sort of worked out, okay, well how long is the whole sperm, and it's about, to me it looks about 34. So how many of this width can I fit into 34? And that sort of came to about 7. So I sort of divided it and I worked out that you could probably get that head, that X, into the whole length about 4.5 times, and that is approximately 11 micrometers. But if you've got anything between 10 and 12.5, that is fine, because at the end of the day it just says estimate. Okay, question 2. Now this one, again, long question, but make sure you read it all because there's clues in the question. A student wants to determine the concentration of the solution inside potato cells. The student cuts the cylinder from a potato and measures its mass at 2.23 grams. Notice how it always highlights anything that's got numbers. She then places the potato cylinder in a beaker containing sugar solution. After 24 hours, she measures the mass of the potato cylinder again. It is now 1.76 grams. Calculate the percentage change in mass for the potato cylinder. And lastly, and most importantly, give your answer to 3 significant figures. If you don't do that, you lose one of the marks. This question's only out of 2 anyway, and you'd lose one just for not doing that. Okay, so we need to work out the difference first of all. 1.76 take away 2.23 equals minus 0.47. If I divide that by the original mass and multiply it by 100, I get minus 21.07. But because it's 3 significant figures, it's 21.1. And that's the answer. Okay, again, this is a long question, and it's actually quite straightforward to do, because if you can see, they haven't given you any lines to do any calculations on. Another student carried out a similar experiment by placing potato cylinders in different concentrations of sugar solution. He produced the graph on the right, which shows the percentage change in mass of a potato cylinder against the concentration of the sugar solution. The concentration at the x-intercept is the concentration of the solution inside the potato cells. That's my clue. Find the concentration of the solution inside the potato cells. Now, if you'd gone straight to just reading this sentence at the bottom, you would have missed out on this clue here. Essentially, where the graph crosses the line at x is the reading that you need to take. So if you have a look very, very closely, you will see the answer is 0.3. And that's all you need to do for that. Okay, so question 4. This is an equation calculation, and you're actually given the equation. But is it always that easy? Especially when it's for 2 marks, you should be thinking, okay, if I've got to do 2 things, then I've got to do something a little bit more. And that's a clue there, when it tells you the conversion of 1 centimetre. So a patient has a heart rate of 70 beats a minute and a stroke volume of 0.074 decimeters cubed. Calculate the patient's cardiac output and give your answer in centimetres cubed per minute. Now straight away this is easy in terms of it gives us what we need to do. So it's the stroke volume times the heart rate. Well, the stroke volume is, we worked it out, is 0.074, but we need the answer in centimetres. So we need to convert that first of all. So if we multiply that by 1,000, that's 74. Now if I put the numbers in, 74 times 70, the cardiac output is 5180 centimetres cubed per minute. Okay, this question then is looking at some data, and we've got to take some data from a graph. A group of scientists are recording deforestation in a rainforest in Central America. The chart below shows the area of forest remaining at the end of each year over a 5-year period. Calculate the percentage decrease in forest area between the end of 2012 and the end of 2016. So first of all, I only need to work out the bars for these two. So I use my ruler again, and I actually go across. So 2012 is here, and 2016, I go across very carefully, is here. And then I can take those readings, because I need to work out those readings so I can work out the difference. So in 2012 it was 1900 kilometres. In 2016 it was 400 kilometres. So 1900 take away 400 equals 1500. I divide that by my original mass and times it by 100, and I get the answer of 78.94. Now this next question is asking you to calculate the average rate of deforestation between the end of 2013 and 2015. So this time I look at 2013, and I'll do the same again, use my ruler to go across, and I use the 2015, same again, well that's 500. 1750 take away 500 is 1250, but this time, because it's the rate, I want to know how much I'm losing per year, so I just divide it by 2, and the answer is 625. So on to the last little test. Thank you for listening.